been supporting us on SDN work is part of AmLight. The exchange point, which in a sense is the nexus between North America and Latin and South America, which is fantastic work that they do here. So Julio's going to talk about the transition of the AmLight backbone to SDN. Thanks very much.
Thank you, David. And thank you all. It's a pleasure to be here, hosting you all here in Miami. I recall that we've had numerous conversations over the years to see about having the GLIF here. We finally achieved that, and I'm happy that you all are here in spite of it. This is September, our busiest and most active month for hurricanes, and also with our Zika situation. But you all persevered, and I think we're having a great week in terms of weather, and we're really very happy with that. So I wanted to use this opportunity to provide some historical information about work that we've done with a project we call AmLight. Most of you have heard presentations about this over the past few years. For some of you who don't, this will provide an introduction and also give us an opportunity of trying to clarify some of the work that we've done with both traditional networking and software-defined networking. So the team that leads the AmLight project, along with our partners in Latin America, are listed here: myself, Heidi Morgan, Donald Cox, and Geronimo Becerra. Geronimo is here in the back, and we also have Professor Luis Lopez from ANSP Sao Paulo joining us as well. As I mentioned, I'm going to give a little bit of context about what AmLight is, some historical background, and then talk about what we did with SDN and how it shaped our project and even our center at the university. And then some of the impacts and motivations for doing this. So the AmLight project is a project of the National Science Foundation. That's how we got this project started back in 2010. The award number is listed there in case you want to look it up in the awards database. And basically its goal is to support the needs of US, Latin American research and education communities to advance discovery and scholarship within the region. This shows the ecology of the network at the conclusion of the project in 2015. Now, we've done much work since then. We now have a successor project, which we call AmLight Express and Protect. If you were here for the TechX, you heard me and Geronimo talk about this. So just bear with us if you have. But so this project is currently active, started in 2015 and running to 2020. Another project with the support of the National Science Foundation as well as our partners in Latin America. Its major contribution is that it's going to introduce spectrum capacity between the US and Brazil. You heard Jeff Cantor this morning talk about LSST. That is one of the main science drivers for moving in this direction as well as some of the evolution going on with undersea submarine cable systems within the region that we've been able to use opportunities to acquire spectrum with these new cable systems. So it gives us an opportunity to continue the goals of the project, which is to evolve a rational network infrastructure, in this case now using both spectrum and lease capacity. This is what the network looks like today. We have two 100 gigabit links in operation, one on the Atlantic side, a second one on the Pacific side. There are 4 10 gigabit links as well, with landings in Sao Paulo, Fortaleza, Santiago, and Miami. This amounts to 240 gigabits of aggregate bandwidth capacity serving the region. And we will be adding Fortaleza in Brazil and Santiago in Chile to the ring by November of this year. So now let me switch context and talk a little bit about what we did with SDN, introducing it into the AmLight project, And this was a project in and of itself that was launched back in 2014 and planned in 2013. You have a slide here of a presentation that Geronimo gave at a GLIF workshop in New Zealand back in 2014, where he introduced our work with SDN in the AmLight project. So some of the key motivations to use SDN. One was we wanted to improve operations efficiency on the AmLight project. We learned that we can hand off layer 2 provisioning to our users on AmLight through the use of SDN, and also improve layer 2 multi-domain provision. We've enabled the use of IDCP with Oscars, and also NSI with OpenNSA, and this is something that we've been able to confirm its capabilities in the operation of these tools and protocols in a production environment. It allowed us also to introduce network programmability. So now our users could actually start to program network functions through this capability. And we deployed network testbeds, managing the network infrastructure, and did this, we learned how to do this in a secure way, and also how to add and evaluate new control planes in parallel. In a later slide, I'll talk a little bit about some of the test beds that have been deployed to do this and confirm this work. We were able to also measure some of the improvements of using SDN and OpenFlow for improving operations efficiency compared to when we're doing this manually. So for example, with the provisioning of a circuit, the average time to provision a circuit before SDN on these networks here, if we were working with RNP, ANSP, typically the average was about 5 days. Once we had OpenFlow enabled and these tools available, we were able to do this within 5 minutes. One of the things that also occurred, as all of you know, working with in provisioning circuits across multiple network domains, if you're doing this with a manual process, a lot of emails have to be exchanged as well between all the different network groups. We measured that before SDN, it would take, on average, about 10 emails. After SDN, no emails were necessary. Working with also with Oscars and NSI support, we were able to really improve the provisioning time as well. Before SDN, it would take about 12 days in working with all the network operators, and on average with emails, about 65 emails we measured were exchanged. We had a successful publication of this as well. The citation is listed here in the bottom, and is available as well on our project website, sdn.amlight.net. With network programmability, we were able to add quite a bit of functionality as well for our users. So before SDN, SNMP was available just to being able to view the topology and gather some data from the network. Provisioning defined by the user was not available. With multipath experiments, things had to be set up statically. And then flow control hop by hop was not available as well. But with SDN, we had now visibility through SNMP as well as with OpenFlow, and then full OpenFlow access was available to the users for them to be able to program the network through a dedicated slice. Some of the lessons that we learned from the experience, well, SDN and OpenFlow have the potential of helping in many ISP activities. For example, with multi-domain provisioning, it really made significant improvements in our efforts to streamline operations and become more efficient as an operation, and also collaborating with our network operators in the AmLight project. We did realize as well that a lot of caution is necessary before you deploy an SDN application into a production environment. Most of our collaborators and all of you as well that have deployed experimental testbeds with SDN, you pretty much have it in a separate network or in a testbed environment. We've actually done this with a production environment, and we've gained a lot of experience in doing this. And you definitely do have to be cautious. And we learned a lot of this as well from working with Internet 2 in the process, and RMP and ANSP, working with the GR NOC in adopting some of the methodologies that they've used and making some improvements to it as well. But it also gave us the opportunities of learning new technologies. For example, most OpenFlow switches, when we worked with them, we discovered that had immature code, so a lot of messages came in improper formats, and so we had to take a defensive posture in making sure that that didn't cause crashes to the network. The other component that was also made things challenging was the troubleshooting of these environments. So troubleshooting is a very time-consuming process. In most cases, vendors lack proper tools for troubleshooting, and we ended up spending a lot of time with vendors in trying to identify where the problems were. This led us then to realize we have to develop some tools to help us with this. And I'll talk a little bit about some of the tools that were developed as a result of this work. So the immature OpenFlow code, this results in risks, potential risks being introduced into the production network services. So you have to be aware and take a defensive posture to this, is our best recommendation. So we had devices crash due to unsupported OpenFlow messages, and you need to take steps to validate your OpenFlow software as a precaution. One of the methods that we used to help us with the validation process was to use slicing. So slicing proved to be very effective and useful for testing different control planes. So it revealed potential risks that we were able to then just safeguard before deploying into production. And it also allowed us to realize that this was a way to encourage researchers to start using slicing as a testing methodology. So we encourage researchers to bring us their applications and allow us to work with them in creating a testbed and in a slice for them to then test their applications. So with all of these new technologies, as you all know, technology often has a shaping effect on organizations, and it certainly did for us as well. So one of the things that occurred was some culture changes within the AmLight project and within our organization. So for example, with the network engineering team, the whole shift to working with SDN and OpenFlow was to take on a new, more expansive mindset of starting to use programming as a way to implement the network. So the engineers got exposed to tools such as the Agile methodology and Scrum, coding with Python, Java, validating with Unitest. These are now part of the operational discussions that the engineers have on the project. Training now is more than just going to a CCNA or a Cisco course or a Juniper course. It involves learning some software methodologies. So courses such as for network engineers was one of the starting points for us. And now we have a stronger focus on software and not just on programming hardware. So the team was trained to follow a software methodology such as Scrum and Agile. And now we're also involved with some collaboration with the ONOS development. which is a great opportunity to really learn more about a network operating system and with the developers of it. So, some of the main challenges with our engineering team is how to continue working with convincing the network engineers, and not just the management team, but with some of our traditional network engineers, how SDN might be useful in the work that they're doing, and being a new paradigm in the networking engineering community. We've had our successes as well as our failures. And then once we've learned that our engineers, and not just speaking for AmLight, but as well with our colleagues in the AmLight project, that have a more, I would say, inflexible organizational structure in terms of how to manage production networks and being able to support experimental testbeds on production networks. It is a culture change, and once you start to make inroads, the training aspect becomes very important. And so we've had some successes in getting people to take these courses and use tools such as lynda.com that provides some of these courses online for them to be able to learn about them when they have some time. So this has resulted in some identity crisis that we've tried to mitigate. And like for example, situations like what kind of an engineer or network engineer we're shaping and trying to develop towards future projects. And so we've come up with like a term, Network Engineer 2.0, and seeing how we can clarify what that means. Could it be a DevOps or an SDN research engineer? We don't know yet, but we're trying to figure that out as we go through this. I can say that recruitment is a challenge, and we continue to try to persevere in that area. But I think it's worth the effort, and we're going to continue doing that. So, with that said, some of the results of these efforts have led to some new projects. You've heard about the Atlantic Wave SDX if you were at the TechX. We do have a demonstration this evening that colleagues from Georgia Tech, Sean, forget your last name, Sean. Sean Donovan and Russ Clark are here from Georgia Tech. And so this is, I think, is going to be an exciting project for us, leveraging the AmLight infrastructure. As I mentioned, the AmLight Express and Protect. And then we've also been able to attract some undergraduates to work on these projects. The Switch On project is a project based at FIU in collaboration with computer science there to support the future internet architecture community, and between the US and Brazil. And then the LSST, we see the SDN work that we've done as being very important with supporting LSST, in particular with the integration of the optical spectrum and the least capacity links that we'll have within the region. And one of the things that also has emerged from this, with our collaboration with ANSP, we've been working with Luis Lopez and ANSP for the last 15 years, and we're now at a point where we've actually merged our IT teams, and we have developed a unified approach to being able to support US-South American connectivity. So we have a few of the engineers from ANSP here, Rogerio and Antonio, that are spending some time with us here in Miami, and we're really pleased about them. And likewise, we've also been able to get involved with the Open Laboratory for the ONUS development, which is a great opportunity for our engineers and future direction. So, outreach activities, well, you know, we've done quite a few presentations now on our OpenFlow work. 41 presentations. We've submitted 5 papers on our experience working with OpenFlow and SDN in a production environment. Developed 3 tools focused on troubleshooting. Have implemented 6 network test beds, including ONOS, the fiber project in Brazil, and demonstrations. You can find this work here at the SDN AmLight.net site. It's all available there for you to review. Let me just spend a few minutes here quickly on just giving you a brief description on some of the tools that we developed with the AmLight project. So there is a testbed sanitizer, and this is something that we did in conjunction with our colleagues at the GR NOC and Internet 2, because we realized that the OpenFlow messages, the way that they're implemented, are not they're not robust, and we had to take a defensive posture in making sure that it didn't crash the network. So this sanitizer created a security layer between the OpenFlow switch and the OpenFlow applications. So this was very good work that we then were able to inform our vendors about how they can help us to make sure that their implementations are improving with their technologies. It was a proof of concept, so we don't actually have a prototype available for you. But the next tool, the OpenFlow Sniffer, this was presented at the TechX in 2015, and this is being used to monitor the control plane communication between switches and OpenFlow applications. This is available to you, the URL here for GitHub. You can refer to that. But this is something that we've also published on, and it's a very good tool. I have to say that it really does provide some very useful information. And then an SDN trace tool. Geronimo presented on this at the TechX here this week, and this tool will help with tracing the data path of OpenFlow networks. So it will help you validate your data path. And so these are all tools that we've been able to really help with the implementation of these SDN applications in a production environment, as well as pass on results to vendors for them to keep improving their OpenFlow implementations. We've also done some work with OpenNSA as a backend to OESS. So now our network collaborators and users in being able to create dynamic circuits are able to use this environment with their applications. So these are contributions we've made with our work in SDN, and I hope that you can talk to Geronimo, talk to our engineers, let us know of your experiences, and hopefully we can collectively move this technology further along. Some of the goals that we have for the future is to install and manage the spectrum using SDN. This is going to be, I think, a challenging effort for us to integrate packet and optical layers, and we're hoping that SDN will help us achieve that. We will deploy the SDX controller into production. This is, if you all had the opportunity to see, or some of you, if you had the opportunity to witness the presentation that Sean Donovan gave, I think it was yesterday, right, Sean?
Yes.
A very comprehensive presentation on the design of the SDX, and I encourage you to talk to him this afternoon at the demo. I think it's very, very interesting work that I think will make a significant contribution to the community. and the SDX project supported through the IRNC program. We plan to migrate to OpenFlow 1.3, and as far as tools, we are developing an SDN looking glass. So this will provide a unified GUI interface to operate OpenFlow networks, and give you some important information that you can measure some of the objects that you'll have within your OpenFlow environment and SDN environment, such as your slicing technology, your virtualization, give you full network visualization, because we really need these tools for troubleshooting. The environment has become a lot more complex, and we hope that you'll engage with us in some of this development as well. So we're estimating to have a prototype, a first version of this available in February 2017. And to conclude, I will say that the experience with SDN has pushed AmLight to reinvent itself. It really was a shift for us to work with this new technology, and our goal is to continue learning how to operate SDN in a production environment. In some cases, we realize that you make some trade-offs with this technology, like for example, CapEx increased in being able to deploy this technology in a production environment. We had to make some investments in adding more ports and more hardware, but once we got the environment stabilized, we were able to observe that the OpEx doesn't necessarily increase as well, in particular in supporting users. We do have some anecdotal results in saying that OpEx will increase in interaction with vendors, but that's just part of the work that we have to do. Troubleshooting will continue to be complex and time-consuming, but we hope that will improve over time. We see that this technology does facilitate development of SDN applications, in particular working with the virtualization environments and being able to deploy applications within slices and use that methodology as a way of insulating the test beds from the production environment and encouraging researchers to bring us their test beds. So, share with us your experiences, and we hope that we can really move this forward with our research community. So, after 2 years of working in this area, I can honestly claim that we consider the investment in SDN a success, and we continue to look forward to making more progress in this area and enhancing our collaborations with our R&E colleagues in the GLIF and international partners. So thank you very much. And my concluding slide here, thanking all of our colleagues and sponsors with our project. And my contact information if you need to contact me or any of our